Hi there folks, welcome to video 4 of this Python Pygame project series, making Othello, also known as Reversi. This is the 4th video in the series. In this video, as discussed in the last episode, there's going to be quite a bit of detailed logic, a lot of searching in the grids, a lot of checking. It's fairly complicated. I'm going to try and work through it as clearly and concisely as I can. At any moment, if you get stuck, please pause the video, have a look at what it is that we're doing, and try it again. I always find the best way when I'm following along on other tutorials. When I follow along on other tutorials, I like to comment out certain sections of code to see what each code does, each line does, make changes. Normally, it helps with the way I learn, so sometimes it might help you. Alright, so in the last video, we inserted tokens onto the board. In this video, we're basically going to be working around finding what are the available cells what are valid cells that can actually be played by each player each turn, and if that cell is a valid cell, then to insert a token, and then I think we might even move on to, once that's happened, then we'll see. Well, let's see how far we get with this section first. Right, so let's get into it. So firstly, I'm going to go to my game here. I just want to go back to appearance presentation mode. I think it's a lot easier for you guys to read what's going on the screen. The first thing I'm going to do is I'm going to go to my regular grid class, and here below my print game logic board method. So right here below my print game logic board method, I'm going to create a new method. I'm going to call it find valid cells, and I'm going to pass this method two arguments. I'm going to give it a grid and current player. Okay. Right, and let's just get a little comment. Performs a check to find all empty cells that are adjacent to an enemy opposition to opposing player. Okay. So to start this off, I'm going to start it off with a valid cell to click and make it an empty list. Right. Then we're going to cycle through the grid itself, as well as, okay, so now we're going to just cycle through come on, spell correctly, for grid Y, column in enumerate row, right? So firstly we're going to say, well, if grid X, grid Y does not equal 0, right? It must then move on. So basically, as it's cycling through the game logic, the grid board, as it's cycling through that, if that particular cell is not a 0, it must just move on. It must skip. It must move on to the next item in the for loop, right? Because it's an empty cell. It's a completely empty grid, empty square. No, wait, it's not an empty square. It means that it's an occupied square, which means there is already a tile in that square. Whether it be a black tile or a white tile, it does not matter. It's an occupied space. Therefore, the rest of this loop no longer applies. Okay, so it moves on to the next item in the loop. Okay, so once it's performed that check and it passes that check, we will then create a variable here called directions. And we're going to create a utility function. I use this as a utility function. Originally, I had this here under all of these directions included here. It made it a little bit bulky and cumbersome. I did it this way. I think it might be a bit better. You'll see why in a moment. Okay, so we're creating an item, a function called directions, and I'm just typing it in so that you can see what's going on. Wait, let's just create the function first. So let's go up to the top, all the way to the top, under my utility functions, right at the top. I'm going to call it def directions. And I'm going to give it a couple of arguments. I'm going to give it the x argument, the y argument, a minimum x argument, which equals 0, right? A min y argument, which equals 0, a max x argument, which equals 7, and a max y, which equals 7, right? So those are default arguments already. I'm just going to give it a comment so we can remember what's going on. Check to determine which directions are valid from current cell. Right. So as we're looping through the grid and you get to the very first position in a row, it doesn't help you look to the left of that item. Because if you try and perform a grid index position looking to the left, it's going to tell you either it's going to give you an index out of index error, or you'll end up looking at the end of the row, the list, instead of off the list, if you understand what I'm saying. So what we're doing here is we're going to say valid directions. So in this function, we are literally just determining all of the directions that we should be looking: north, south, east, and west. North, south, east, west, northeast, northwest, southeast, southwest. So all 9 points. Am I right? 9? Is it 9 or is it 8? North, northeast, east, southeast, south. I've stopped counting. I wasn't even counting. That's useless. Anyway, you get my drift. So we're going to say if x does not equal min x, right? So if x does not equal min x, which we said was 0. So if x does not equal 0, valid directions dot append, and we're going to say x minus 1 and y. Right. So basically we are going to be feeding this function the x grid coordinate, the y coordinate, and then into our valid directions we will be, if the x is not equal to 0, we will then include into our valid directions a valid directions list, a tuple of the x minus 1 and a y. Okay? Then we're going to say if x does not equal min x and y does not equal min y, valid directions dot append, and then again we're going to have x minus 1, y minus 1, right? And then we're going to say if x does not equal min x and y does not equal max y, right? We're going to say valid directions dot append x minus 1, y plus 1. So what we're looking at there is, if you have to look at the grid, you've got the 3, 6, 9 squares, the square in the center being the actual grid we're looking at. We're busy looking at the top x, the north square, the northwest square, and the northeast square. That's what we just looked at right now. Okay. After that, we're going to perform the next function. We're going to say if x does not equal max x, valid directions dot append x plus 1 y, and then if x does not equal max x and y does not equal min y, valid directions dot append x plus 1, no, it needs to be a tuple, x plus 1, y minus 1. And then if x does not equal max x and y does not equal max y, valid directions dot append x plus 1, y plus 1. So that's the bottom 3 rows, right? Then the next thing we're going to do is just the middle 2 rows. We're going to say if y does not equal min y, valid directions dot append, what is it? It'll be x and then y minus 1, and then it'll be if y does not equal max y, valid directions dot append x y plus 1. Right, once that's done, we're going to then return our valid directions list. No, what are you doing? Directions. Excuse me. Great, that's fantastic. We've just created our utility function to determine which directions we should be looking into. Right. I just need to go down and check out, find our directions. Okay, we find valid cells, Right, directions. Remember when we created our directions function, we're going to need a couple of arguments. Well, they're all default arguments. We just need the x and y. So our x and y position will be our grid x and our grid y. We don't need to pass it the min and max, but let's pass it anyway, because we're working on a total of 8 rows, so it'll be 0077. This would actually be self dot rows, no, self dot main, no, game dot rows, no. Where did we have the rows argument? Didn't we have a rows argument there? Self dot y is equal to rows, self dot x is equal to columns. Right? Rows, columns. Self dot y. It would actually be that. Although that would be 8. Anyway, self dot y and 7 and 7. Okay, that's our directions. Right. Let's be fair, we can just take that out. Okay, for direction in directions. Alright, direction x, direction y is equal to direction. Okay, because direction is a tuple, so now we've just got our direction x and our direction y. We're going to say checked cell is going to be equal to grid direct x dir y. So that is our checked cell. Okay, so that is the cell we are busy currently checking. So then we're going to say if checked cell is equal to 0, or checked cell is equal to current player, just move on. Just move on, right? Because it's an empty cell. Right. We're then going to say if grid x, grid y is in valid cell to click. We're also going to just continue. If checked cell is equal to 0, of course. Okay, right. So when we did this directions function over here, we wanted to find all the cells that were already empty. Right? We were looking for the cells that were all the cells that were surrounding a player tile. Let's just go up quickly and double check what I'm saying here, if I remember correctly. So we're looking for the directions. So we have a tile in here. So now we're checking all the directions around that particular tile, around that particular square. Right, valid all the, okay. So if we come back down here to our find valid cells, so we're checking. So if we find a tile that does not equal 0, so it's a player tile, right? We skip. So if we find an empty tile, we then find all these directions. So we found an empty tile. Right. So now we have an empty square. So now we're checking all the directions around that empty square. Right? So all the position around that empty square. So say now we have, how can I explain this? We have a square at A2, right? So now we're checking square A1. We're on A1 square, and now we're checking all the tiles around A1. So A0, no. B1, B0, no. B1, no. B2, no. A2, yes. There is a player there, an opposition player there. So if all the tiles around the current cell is still a 0, it's an empty square, well, then we're just going to continue because it doesn't mean anything to us. Or if it's the current player, it doesn't mean anything to us. We're looking for any tiles that are around our current tile that are of the opposite player's color. It'll make sense in a moment. I'm sorry, this is, like I said, this is quite difficult to explain. The first check that we did was we were looking for a tile that was, to make sure that it was empty. Once we found the tile that was empty, now we're looking at all the tiles around the empty tile to find that it has a tile of the opposite player's color. If there is a tile of the opposite player's color adjacent to the tile that we're on now, it is then a valid tile that can be clicked on, that should be able to be clicked on. Yeah, I think that made more sense. Yeah. So now we've performed these two checks. It's not all the tiles around it are not zeros or the current player, and the current cell is not already in my valid cell to click. Right? Then we're going to say valid cell to click dot append grid X grid Y. Okay. Once all these checks are done, we're going to return that valid cell to click list. Like I said, this is a fairly complicated thing to explain. Yeah. Basically, we're looking at each empty cell, and we're trying to find which empty cells have an opposing player's tile next to it. That's what we're looking for. That's what this entire function does. Okay. Where did we call this function? We called this function. Where do we call this function? Where do we call this method? My apologies. I just want to check. Okay, so we've built this method. We're not calling it anywhere yet. What I think we're going to do is we're going to call it in our draw grid method. So in our draw grid method, where's my draw grid method? Underneath my draw for tokens, are you kidding me? Oh, it's fine. What we're going to do is we're going to say available moves, right? We're going to create a variable. I'm going to call it self.find valid cells. Find available moves. No, hang on. I'm getting ahead of myself here. Right, I just double checked what we're going. Okay, so I did warn you at the beginning of the video that this was going to be a very technical episode. Okay, so we've just built the find valid cells. Okay, so we're finding all the squares that are adjacent to an opposing player's square. That does not mean that they are actually a playable tile. They're just adjacent to a black or the other team player's color. It doesn't necessarily mean that they are playable. So now we need to build a method to check that they are actually playable. And this means that there's going to be two more methods that are being built that are fairly large and quite quite difficult. So we found the valid cells. Next, we're going to build right below this. We're going to make a method. And we're going to call it diff find available moves. Right? We're going to pass it to self. We're going to give it a grid argument. We're going to call it the current player. Right? Again. Right. Takes the list of valid cells and checks each to see if playable. Right? Alright. So we're going to say the valid cells is going to be self.find valid cells. And we're going to pass it grid and current player. Okay? Then we're going to make another list called playable cells. And that's going to be an empty list. Okay. So now we're going to say for cell in valid cells, for cell invalid cells, x, y is equal to cell. Okay. Now we're going to create a variable called swap tiles, which is going to be a list, and that's going to be equal to self.swappable tiles. Okay, swappable, not null, swappable tiles. And we need to build another method in order to do this. So we're going to define another method called swappable tiles. Swappable tiles, the arguments are going to be the x, the y, the grid, and the player. Right? So we're going to have surround cells will be equal to directions. Okay, we're calling that utility function again. X, Y, 0, 0, 7, 7. We don't need that actually. Okay. And we're going to say if len surround cells is equal to 0, we're going to return an empty list. Okay. Then we're going to go and we're going to say swappable tiles will be equal to an empty list. And this is where we get into some of the fun stuff. So we're going to say for check cell in surround cells, check x, check y is equal to the check cell because it's a tuple. Diff x, diff y will be equal to check minus x, check y minus y. Check x minus x, check y minus y. Right? And then the current line will be equal to an empty list. Alright, we're going to do this in a while loop. So we're going to say run will be equal to true while run, so local variable run. I'm going to say, okay, if grid check x, check y is equal to player multiplied by -1, then the current line dot append check x, check y. Okay. And we're going to also say, well, if grid check x, check y is equal to the player, we're going to say run will be equal to false, and we'll break the while loop. Yeah. Then we're going to go with if grid check x, check y is equal to an empty space. Ooh. space, the current line must be cleared. And run will equal to false. Okay? And we're going to say, well, check x must be plus equal the difference of x. And check y must be plus equal diff y. Right? And we're going to say, well, if check x is less than 0 or check x is greater than 7, or if check y is less than 0, or if check y is greater than 7, then we're going to say, well, the current line dot clear. Okay? And run will then be false. So that's how we break out of that while loop. So once that's done, we're then going to come down outside of the while loop, check your indentation, and say, well, if the length of my current line, right, is greater than 0, then my swappable tiles dot must be extended with my current line. And if that's the case, we're going to say return my swappable tiles list. Okay, that was a mouthful. Now let's quickly just go through this method quickly. Okay, so the first thing we've done is we've got our surrounding cells. Okay, so we've passed to the swappable tiles in my find available moves. We're going to pass to it our current cell to check, right? Then for our current cell, we're going to pull out all of the surrounding cells from our current cell. Once you've got all of the surrounding cells, well, if none of them are zeros, if none of them are empty spaces, we're going to return an empty list. Okay? Then we're going to create a variable. So if that's not the case, we're going to move on. And we'll say, okay, my swappable tiles list is an empty list. And then we're going to go for check cell in my surrounding cells. So for each of the cells now surrounding the original cell that we've checking, so each of the cells around it, we're now checking each one of those. So for check cell in surround cells, so my check x, check y is equal to my check cell grid coordinates. My diff x and my diff y will be equal to my check x minus my check y. My check x minus x, check y minus y, right? So that's these positions here. Okay? And then I have a current line list, empty list. Right. Then we go into a while loop. So now we're checking if my grid check x, check y. So my first check cell is equal to the opposite player, right? Current line dot append check x, check y. Yes, opposite player. That means the tile is next to an enemy position. That tile that I'm checking is an enemy tile, right? Or an opposition player tile. That's good. I want that to be included into my current line, my empty list. All right. We'll go on to say, well, if the grid check x check y is also equal to the player, then it must. Well, that's not going to. It's going to read false. This should actually be. I wonder if we could run this as an aleph. We should probably run this as an aleph. It doesn't matter because then it performs. Well, it's performing the same check. It doesn't need to perform the same check again. It should be an aleph. We should run it as an aleph. Aleph, right? We don't need an else though. Aleph. If that's the case, okay, cool. Move on. If that's not the case, I'll go into that one. If it's not equal to opposite player, if it is equal to the player, run is equal to false, and we break out the while loop. If it's not in player to the current player or the opposite player, it must just break out of the while loop. Right. Okay, that's good. That's good. That's good. That's good. That's good. Right. All right. So what we've it's performing a check. So that means it will be checking A. So if my tile is currently at A3, or let's say C3, it will, and we go B2 as a opposite player, it'll then say B2. It'll add that to my swappable tiles list. And then it'll then again check A1, because that's what this while loop is doing. It's moving along each direction. It's moving along each direction to check if it's still valid tiles. Right? It'll then, what it'll then do is that it then changes my check X or check Y position. All right? Goes cycles through the loop again, and it now checks a new tile or a new square to see if it is a valid tile or not. Hey, come on. Right. Once it's broken out the while loop, and then it checks that to see, well, is the swappable tile, is my current line greater than 0? So is the length of my current line actually greater than 0? If it is, it will add that line to my swappable tiles list and returns me that list. All right. Oh dear, sorry. So then we go back to my find available moves, swappable tiles. We're going to pass it the X, we're going to pass it the Y, we're going to pass it the grid, and we're going to pass it the current player. Okay, swap tiles. Then we're going to go, well, if len swap tiles, come on, swap tiles is greater than 0 and cell is not in playable cells. Right? I'm going to say playable cells dot append cell. Wow. So we're doing that entire exercise on every cell, even if the cell is already in our playable cells list. You know what we should do is we should actually go here and say, well, if cell is in playable cells already, we should then continue. That should still work. I'm just going to comment this line out so we remember it. I'm just going to say if len swap tiles is greater than 0. Right? Let me just move that below this commented outline because it looks bad. Okay. So what I've decided, what we're going to try here rather, so when we're going through this, we're going through each cell in this valid cells list, right? X and Y cell. What we were doing is we would then perform the swap tiles exercise on every single cell. What if that cell was already included in my playable cells listing? That could happen actually, because you would have cells next to each other that might actually still be valid tiles. So what if the cell, it might be included in another tiles, valid tiles, tiles that get swapped over. It would just recursive loop, let's put it that way, or a never-ending loop. So what if the cell is already in playable cells, we just continue onto the next cell because we don't want to have to perform this exercise every single time. Let's save it like this for now, and if we run into any issues, we'll come back and swap it back. So return playable cells. Look, it's not going to make any noticeable difference. You're not going to notice any performance jump or anything like that. But we don't really want the computer performing unnecessary calculations. So let's try and improve it like that. See, that's how it goes. You're supposed to try and improve your code as you go along. Yeah. So I now have the find available moves built up. Now I'm going to go to my draw grid, my game grid to screen, and I want to draw these available moves to screen. So in my diff draw method, no, not for the token, don't go to the token, go to diff draw grid. Where's my def draw grid? Why is it all the way up there? Why is my draw grid above? My draw grid should not be above. Ugh, it really doesn't matter. Okay, in my draw grid method, we're going to say, we're going to create a variable called available moves. That's going to be equal to self.find available moves. And we're going to go with self.grid logic. And then it's going to be self.game.current player. Right? Once we have that, we're going to for move in available moves, pygame.draw.rect window. White will be the color. The x coordinate of the rectangle is going to be 80 plus move position x multiplied by 80 plus 30. 80 plus, where does that 30 come from? I'm not exactly sure. We'll have a look in a moment. I can't remember what that was for. Plus 80 plus move 0 multiplied by 80 plus 30. Oh, it's because of the size of the rectangle that we're making. That's why. Okay. If we run this now, we should get some little white squares on the screen. We need another one of these. Yeah. Would you look at that? And then if I had to click this cell with a white, turn it to a white, it should turn to the black color player color. So that's a black square that can be played. That's black 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 that can be played. See? Obviously not. Obviously we're not switching over the color of the tiles currently. So we're not swapping the tiles. But it's still selecting according to the tiles that is in the screen what is playable. What is playable. So that's white. Okay, so for black, all of this is playable. That's playable. So that means for white, all of that's playable. So that is working. It is working. Those methods we just built are working correctly. We still need include a few other items, but it is working. The only thing I want to do now, which I think we can include in this video, although it's already gone pretty long, on our input. Yes, in our input. So if we run the game currently and we click here, we can add a square there. We shouldn't be able to add squares over here, or there, or there, or there. It should only be in those two recommended spots. We should only be able to add cells there. So what we're going to do now is we're going to quickly add a check in our input method in the original Othello class. Under the input, we're going to put in a little check. So here, in our event button number 1, xy is equal to blah, blah, blah. We're going to say valid cells will be equal to self.grid.find available moves, self.grid.grid logic, self.current player. Okay. And then we're going to say, well, if not valid cells, so basically if there is no valid cells, we're just going to move along, else, and we're going to say, well, if yx is in valid cells, right? If yx is in the valid cells, only then will we be able the screen. Right. Again. Okay, we'll do that in the next video. So anyway, so if I run this now, if I click there, nothing happens. See, nothing is happening. If I click off there, nothing. But if I click on that square, it works. Just one more, guys. Just one more. It works. But if you click out of there, it does not work. Do you see that, guys? Fantastic. Guys, if you enjoy these videos, if you're following along and you find it helpful in any way, shape, or form, I appreciate it if you could please hit that subscribe button, hit the like button, hit the share button if you want to even. That'd be great. Comment below. Let me know how it's going. And I'll see you guys in the next video. Cheers for now.